Hi all, this is my Coursera assignment for managing ML projects course by Duke University, and this is me, Yuvraj Jnana. The agenda for this assignment is opportunity evaluation. I'll be explaining briefly about the opportunity and why I feel machine learning is the apt solution. Then I'll be talking about CRISP DM business understanding, just to analyze the business understanding of the problem itself, give different facets of it. Thirdly, I'll move on to solution validation plan on how I will solution it and how the different iterations will happen in order to ensure that we are reaching the solution as per targeted outcomes and outputs. We'll also be talking about the machine learning system design. What are the key considerations in order to arrive at the system design? And finally, what are the potential risks when we roll this out to production? That's the agenda. Firstly, let's talk about the opportunity that I have identified. The opportunity is to create a travel app that provides near real time traffic route suggestions based on the current traffic. That's the problem statement I have identified. Why I feel machine learning is the right figment is because there's huge data involved, especially with the maps data and the amount of vehicles that are traveled. There's an obviously intensive competition involved. Especially the problem that we are solving is more near real time. So as you see in the market, there are a lot of apps, but what happens is at the time of um, when you fix the destination point, that's when the route is detected. But then it doesn't change the route when during the time of commutation there is a traffic created. Say, as an example, there is a road blockage. That is the main problem statement that we are trying to solve here. Let's move on to crisp DM business understanding, like sharing what the problem statement is. As I said before, we are targeting mobile users who are commuting, and as I mentioned before, travel app that provides route suggestion in near real time. Near real time is the one that is very different from all the other apps that are available. Why it really matters is, as I said before, from the time you decide on the route and then you start traveling, there could be changing in the environment or the route conditions. That's the problem that we are trying to solve here. And again, that's the same current gap, right? It doesn't, the route suggestion doesn't change during the travel. The success that I would like to define um, is when the average speed of a certain city, will be identifying top 5 cities where the adoption could be prevalent by at least the average speed of commuters in certain cities that are identified by 5 kilometers. Say, for example, this year the average travel speed is identified as 20 kilometer per hour. The success rate is when we provide this app and roll it out, as and when the user adoption is increased, then we reach a success rate of speed of 25 kilometer per hour the next year. That's what I define as a social success. Obviously, the business success is when we capture the market by 50%. Model goal is, of course, to predict the fastest travel time in near real time, or if not real time, if not near real time. Ideal outcome is to make this app the go-to app for all route suggestions. Of course, factors influencing is maps, data availability, internet availability, changing environments such as you have a lot of things that are changing. Say, for example, a roadblock may occur at any given time. The vehicle can be different, right? A smaller vehicle can go into narrow path, But if you're traveling in a huge caravan or something, it doesn't really identify whether the route is up or not. So those are the factors that is influencing. Moving on the solution approach. As with any other solution approach, there will be a set of iterations that will be involved. Firstly, we need to have a mock-up and wireframes of the potential solution. This kind of validates the business understanding. Of course, we all, as a business user and the end user, we need to come to a common understanding whether the end product that we are trying to achieve is in conformance with what the mock-up shows. That's the first iteration. And we'll have to have small subset of historical data as test sample fed into the mock-up model to understand if the business understanding is validated and data understanding is done. Right. So it's the second iteration, and the third iteration obviously is to create a heuristic model. Of course, heuristic is the first step of machine learning. So just create an algorithm that kind of gives an output with the real-time data so that we kind of arrive at the data processing step in the CRISP-TM model. And finally, we feed onto the machine learning model so that the model can be evolved and learned as more data comes. So we'll have to provide the near real-time data so that the machine learning model can be evolved with test training sample set and test run. So of course, we once the model is predicted and we'll have to track and report the performance of the model and continuously improve the model, show the measurement of performance in the form of output matrices and outcome matrices. Moving on to system design, as with the machine learning model, the key considerations are whether this can be a cloud solution or an edge solution. What would eventually work based on my initial thought process is hybrid approach. We can have a cloud machine learning call at regular intervals triggered by edge generated because all the users may not have internet connectivity, so edge is definitely required. But our solution would propose near real-time solution, near real-time road suggestion. So we have to initiate a cloud call certainly, and we need to have internet. That's the approach we would want to follow. The second system design consideration is whether online learning or offline learning. Of course, this being a near real-time model, online learning is a must because the traffic patterns need to be observed at regular intervals and predictions need to be done. So online learning is a suggested model. Of course, it is little intensive, and that's where the machine learning model will have to evolve. Finally, we'll talk about the batch prediction versus online prediction. In this case, we go ahead with online prediction because in regular intervals we'll have to have changed road suggestions. And finally, what could be the potential risk in one-way rollout to production? Of course, data latency. As I mentioned, we'll have to follow an edge-based AI computation. There are cases where the internet may not be available at all. So in this case, that could potentially be a problem. Data drift, of course, there could be some environment variables such as blocked roads. We show a model, but then on that particular day where we are rolling out and testing, the road could be blocked due to momentary decisions. Right, there could be a demonstration on that road for blockage, or there could be an accident. We can predict the traffic, but what if the road itself is blocked or the road is dug? Right, so that's the pattern that we are talking about. There may be no vehicles and nobody moves, but it doesn't mean that in the road we show the road is there, right? So that's the problem we are talking about. So these are the identified potential risks at this point in time. This is could be monitored and revised as we progress in the model development. That's the brief description about the assignment. I hope I have met the expectation. Thank you.